Right? Okay, in this question, the question is asking you to find the critical points, right? Critical points. So it's not only stationary point, but critical point. Critical point is consists of the f prime x to be 0 and f prime x to be undefined. You have to consider two cases here. So that's why they said find the critical point. At this you have a singular point. It's possible for you to have singular point and stationary point. So that's why they said find critical points. So it means that, and hence determine whether the critical points are local minimum or maximum point. That is important. So alright, so we can trying to find the f prime x. No matter how, you have to find the first derivative of this function. So for this function, you doesn't mean that you must use the you can, without using the product rule, right? Because this you can simply just multiply inside. So it means that for f prime x, right? For f prime x, I try to avoid product rule, okay? But it's okay to apply product rule, alright? So I try to avoid, so I'm getting 4/3 because 1/3 plus 1, right? 1/3 plus 1. So 1/3 plus 1, you have 4/3 and x to the power of minus with 4x to the power of 1/3. So I want to use basic rule to differentiate this. So I differentiate this first derivative. So I will getting 4/3 x to the power of minus 1. You have 1/3 and 4x 1/3. Okay, 1/3 minus 1. Okay, so you 1/3 bring down, you have 4/3, right? So remember 4/3 bringing down. 4/3 bringing down, so you have 4/3 x to the power 1/3, 4/3 minus 1. So minus with differentiate basic rule, bringing down this at 4/3 x, x to the power of negative 1/3 minus 1, which is negative 2/3. This is your first derivative here. So I'm going to factorize the 4/3 and x to the power of 2/3. Okay, I can try to factorize x to the power of negative 2/3 here. Alright, so if I factorize x to the power of negative 2/3 here, so this one you have to write as x to the power 1, right? Because 1 plus with negative 2/3, 1 plus with negative 2, you have 1/3, right? So minus with 1. So then I have getting, I modify this function, so I'm getting 4x to the power of 2/3, 4x to the, oh sorry, so it's 4x negative 2/3, right? Negative 2, so it's 4/3 x to the power of 2/3, x to the power of 2/3 and x minus 1. Alright, so this is your first derivative. It's your first derivative. So it's must be be careful. So for this case, your first derivative will be this function here. Alright, so now this is my f prime x. So f prime x. So I have to get, because I want to find the critical points. Remember, they're using the words critical point. It's not stationary point. Critical point contains you need to consider stationary point and also a singular point, right? Where the f prime x is undefined. So for this case, we consider the stationary point first. Okay, we consider the stationary point. So the stationary point here will be your f prime x to be equals to 0, right? So it means that I'm taking 4x minus 1 over with 3x to the power of 2/3 equate to 0, right? This will be 0 if and only if the numerator is 0. So you don't consider denominator. So it means 4x minus 1 is equals to 0. So you are getting x equals to 1. Okay, x equals to 1 is the stationary point. So then you can substitute 1 inside here to getting the value of y. The coordinates of the critical points, the coordinate of the critical point will be 1, right? 1. If you substitute 1 here, 1 power of anything is still 1, right? 1 minus 4 times 1. So 1 minus 4. Okay, 1 power of 4/3 is 1. 1 power of 1/3 is 1. So 1 minus negative 4, you have 1 negative 3. Okay, now this is a stationary point. Okay, it's also a critical point. So now we consider another one, which is f prime x. The f prime x is undefined, as this is a critical point. f prime x is undefined when what? You look at this function here. This function is only undefined when the denominator is 0, right? Is when the denominator is 0, means that 3x power 2 over 3 is equals to 0. So means that x equals to 0 is the solution, because only 0 can satisfy this equation. So 0 is a critical point. It's a critical point, it's a singular point where the f prime x is undefined. So it substitutes 0 inside here, because this value can accept 0. Alright, this one, the domain can be anything, right? Any value of x is okay. So now you have x equals to 0, so you substitute 0, multiply with everything, you are getting 0. Means y also 0. Means 0, 0 is a singular point. So now, then they were asking you to determine whether the critical points, these two, are the local minimum or local maximum point. Alright, very simple. We can use first derivative test, okay, or we can use second derivative test. Alright, so let's see what test that we're going to use here. So, okay, I try to use second derivative test. Second derivative test will be it's actually very tired. So you can, using second derivative test, if you want, you can differentiate start from here. Okay, you can differentiate start from this function here. So let's see what will happen. So, so now I have f prime x to be 4 over 3. F prime is 4 over 3, x to the power 1 over 3, right? X to the power 1 over 3 minus with 4 over 3, x to the power negative 2 over 3. So if I differentiate this one more time, the second derivative test that I'm going to use, so I will getting 4 over 9, right? 4 over 9, x to the power of minus 1, you are getting negative 2 over 3, right? So minus with, okay, negative 4 over 3. This one bring down, you multiply with negative 2 over 3. You have 8 over 9, right? You will turn to be positive, okay? Positive 8 over 9. And x to the power of negative 2 over 3, you minus 1 again. So you are getting x to the power of negative, x to the power of negative 2 over, you minus with 1, you're negative 5 over 3, right? Okay, negative 5 over 3. So you can using second derivative test and you putting all the value here. You're putting 1, okay? You are getting a positive number, okay? That means that this is a relative minimum point, right? This is a relative minimum point. So, but when you're putting 0, it's become undefined, right? So means that second derivative fail. Second derivative fail here, because why? This work, because you're putting 1 here, 1 power of negative 2 over 3 is 1, 1 power of negative 5 over 3 is 1, so you add up these two, you're getting a positive number. So when the second derivative, you get a positive number, that means that this is a relative minimum point. But the problem here is the origin. So if you substitute this into the second derivative, 0, because this is x to the power of negative 2 over 3. So you should bring it down. And you have 9x power of 2 over 3 below the denominator. The denominator will be 0 in these two cases here when you substitute this point. So it means that the f prime x here is going to is not suitable to identify the relative maximum and minimum of this point. So it's only suitable for this one. So if this case happen, so you can actually apply the first derivative test. Okay, because you can't confirm what is here. So this is already confirmed by your second derivative test, right? You have known that this is a relative minimum point. But never mind, for this case, it's failed, right? Second derivative test is not working for this function here. So what you're going to do is, I'm going to do the first derivative test. Alright, let's do quickly about the first derivative test. So we have 0, 0, okay, we have 0 and we have 1, right? So we divide them into 3 intervals. So this is for negative infinity up to 0, and this is between 0 and 1, and this is 1 up to infinity, right? So okay, we just do a simple table. So then we have to inspect the sign of f prime x. Okay, sign of f prime x, and this will be the shape of tangent before and after. So as you see that these cases here, okay, you choose the number. So you can using calculator and okay, key in this function. So I key in for you. So it will be 4 bracket alphabet x minus 1 over with 3x x to the power of 2 over 3, right? So I will key in, I will getting something like this, right? So I getting 4x minus 1, 3x to the power of 2 over 3, exactly this function here. So then I pressing the button calculate. When I calculate, choose a number, don't choose 0, choose a number less than 0. Okay, you can choose negative 1, okay, if you want. You can choose, negative 1, then you calculate, you're getting a negative number, right? So you're getting a negative number for this case. So between 0 and 1, you can choose 0.5, okay? Calculate 0.5 equal, you're getting a negative number also. Can you see that? You're getting a negative number also. So it means that this point is very different. So it's a negative. So for 1 infinity, right? For 1 infinity, so then you can calculate 2, right? 2. Then you're getting a positive number. You're getting a positive number. So means that this is not a maximum and minimum. Means that 0, 0 is neither maximum nor minimum point. Alright? It's not a maximum or minimum point. It's just a critical point. Okay? It's a critical point where the f prime x is undefined. Alright? It's already verified, confirmed that this is a point that the tangent is undefined. So then you have this. Then you have this shape of tangent. So shape of tangent, this one you cannot. Okay. So for 1 to infinity, so you will have positive, negative. So means that 1, negative become positive, right? Negative become positive. So this is a relative minimum point, right? This is a relative minimum point. So, but for this, it will be stay negative. So it's not maximum and also not a minimum point. Alright, I'm going to show you why by using the apps, the Desmos, why this case happened. Right, so as you look at, okay, I have using this Desmos, the apps Desmos, I key in this function, exactly the x power 103 and x minus 4. I can see that this is the graph given, right? This is the graph given. So what can you see during 0, 0, right? During 0, 0 is not a maximum or minimum point. So if I zoom, I can see that is a sudden change. So you see the gradient is negative, right? Negative. That's why you have negative here. And after 0 also, it will be negative gradient. So it's not a maximum and not a minimum point. But if you look at 1, -3, right? 1, -3. So you have 1, -3 here. So I zoom. If you can see here carefully, I zoom again. You can see 1, right? 1. So -3. So 1, -3 is a stationary point, right? And this is a local max minimum point, right? Local minimum point, or we can say it's a relative minimum point. All right. So there is only one relative extremum point here, which is 1, -3. Which 1, -3 is a relative minimum point, and this is just a critical point. All right. We can't say that this is a maximum and this is a minimum, all right? But we know that the f prime x for this case is undefined and is also categorized as a critical point, all right? Okay, that's all for this video.